Hello, this is John Melendez, and this is a lesson on the complement and at least one. Now, the complement is basically the complement is what is not has occurred. For example, if you have an event A, let's look at this. This is event A and this is event B. This is event A and B together, or A or B together. Now, this is A and B right here in the middle, and this is A or B right there. Now, this right here, this is the event A, and the event not A, which is the complement, is the rest of it. So that's the complement, and it's called not A. Not A is called the complement of A. So we have this as not A. The notation is A with a dash on the top. There are several other types of notation, and look at the one in your book, because that's the one that will be used in my stat lab. Okay. Now let's look at this example. The event W is somebody's walking a dog. Well, what's the complement? Not walking the dog, right? So the complement is that it's not walking the dog. How about this one? It's going to snow. The complement is not going to snow. So basically that's what the complement is. Let's say event I is the jury finds the defendant innocent. Therefore, the complement is the jury finds not innocent the defendant. What about if F is the painting is a forgery? Yes. The complement is that it's not a forgery. Now, one of the things that you know about this is this. The event A and the complement of the event A equals to 1. So the event A plus the complement equals to 1. Now that's an important rule that you're going to be using throughout the whole semester or throughout the whole summer. Now, the sum of the two probabilities equals to 1. Let's look at this. The probability that Matt walks his dog on Saturday is 0.84. Find the probability that Matt does not walk his dog on Saturday. We subtract 1 minus 0.84. So 1 minus 0.84 will be 0.16. And that's your answer. The probability that event A happens is 0.372. Find the probability that event A does not happen. So event A is 1 minus 0.372, which is 0.628. And that's your answer. I would like you to work these out. And basically, I will post the answers to them on D2L. Now let's talk about the idea of at least one. At least one, you're using the complement to it. At least one means that you're going to be doing at least 1 or 2 or 3 or 4 or 5 or so on. So it depends on how many you have. Okay? Now, let's talk about this one right here. A couple is planning to have children. The probability that they have a child with blue eyes is 0.25. So now, if the couple has 3 children, find the probability that at least one child has blue eyes. Well, here's the thing. What you want to do is this. Well, let's look at it 2 ways. Okay? Now, the first way is, let's make it be the event that you have blue eyes. And then it's the event that you don't have blue eyes. So we look at the sample space. Okay, the probability of having blue eyes is going to be what? It's 0.25. So what is the probability that is not going to have blue eyes? That's 1 minus 0.25, which is 0.75. Okay, so now what is the sample space here? Well, basically you could have all 3 to have blue eyes, 1 to have not blue eyes, 2 to not have blue eyes, or all of them not have blue eyes. So this is the whole thing that could happen, all of the sample spaces. Now notice that each one of those has a probability attached to it. And we use the multiplication principle to do that. So like, for example, on the first one, which of these families has at least one blue-eyed child? Well, all of these have blue eye except for this one. So we calculate those. We have 0.25, 0.25, 0.25. That would be 0.75, 0.25, 0.25, and so on. We go ahead and do that until we get all those probabilities and add them up. So we add them up and we get our answer, 0.578125. Now the other way of doing this, which is much easier, would be to do this. We can go ahead and find the idea of the complement. In other words, what we have is this. Notice this Lone Ranger here. That's the one that is none of them have blue eyes. Let's calculate that. So we calculate this, we multiply. Now notice, this whole thing's supposed to add up to 1. We can get this amount by subtracting 1 minus this number, and we're going to get this right here, the rest of it. Okay, so basically what we have, we find the idea of not having at least one blue-eyed child and subtracting it from 1. And we get our answer. And that's the answer to that one. Now, let's look at this idea. Let's look at this one, and then I will close this one for this tonight. We have an alarm clock. The probability that a single battery-powered alarm clock will work is 0.92. Now, Emily plans to go to a very important interview to be sure that she is awakened. She sets 4 of the battery-powered alarm clocks. Now, what is the probability that at least one of them is going to work? Well, let's look at that. For an individual clock, the idea that it's going to work is going to be 0.92. So the probability it's not going to work is going to be 0.08, 1 minus 0.92. Now, so we will use the idea of the complement of at least 1. So what we're going to do is find the probability that none of them work. Okay, so now these are independent events because one does not affect the other. So what we have to do is to multiply all the non-works and therefore subtract it from 1. So not at least one alarm clock works. At least all alarm clocks do not work. Okay, so let's look at that. So that's going to be 1 minus 0.92, which is 0.08, multiply 4 times. And then subtract it from 1 to get you your answer. And that's the answer. Please calculate these, and I will send the answers to them. There you go. Let's repeat. So we have example 4. The probability that a single battery-powered alarm clock will work is 0.92. So the probability that Emily, she wants to go to a very important interview, so she puts 4 alarm clocks. We want to find the probability that at least one of them will work. Okay, so that means that we have this. Basically, the W is basically the event that it works. Not working would be N. So we have this. The probability it's going to work is going to be 0.92. The probability it's not going to work is going to be 1 minus 0.92, which is 0.08. Okay, so we will use the complement of at least 1. That means what we're going to do is find the probability that none of them work, and then subtract that from 1 to get our answer. Okay, so we have not at least one alarm clock works. That means that we have all of them that work, all do not work, and subtract it from 1. Okay, and we get our answer. Okay, you can try these. And then we'll try this one. Okay, a tire company produces a batch of 6,100 tires that includes exactly 280 that are defective. Okay, look at this. If 4 tires are randomly selected for installation on a car, what is the probability that they are all good? Okay, they don't say anything about it, but we're going to have to assume that they're not dependent of each other. I mean, they're not independent of each other. We're going to assume that they're dependent. So we're going to take 4 tires. We're going to start one at a time. Okay, we have a total of 6,100 tires. We're going to take 280. So the amount that are defective is 280 divided by 6,100. Now the probability they're not defective it's basically going to be subtracting from 1, and you get your numbers. Now our next step is going to be to find the probability that they're all good. That means we're multiplying, and it's a dependent event, so each time the probability is going to change. Okay, so basically what we have is this. We have multiply 5,820 divided by 6,100, and it goes down by 1 each time. For 1 for that. Okay, now basically what we have is this. That's probably that none of them, I mean that's probably that all of them are going to be not defective. To find at least one defective, take 1 minus this number and you get your answer. Okay, and that becomes the answer. So, on this one, we have to have the practice of redundancy, and we subtract that from 1 to get our answer. Thank you very much for your attention.